Eric Burgess here, and today we have been asked to find the area to the right of z equals 1.92 and the area to the left of z equals negative 0.44. Pretty straightforward stuff if you know a couple facts. So our step one, by the way, we're going to do this three ways. We're going to do this using the chart. We're going to do it using a chart. We're going to do it using a calculator. So hopefully you're using one of those ways. And we'll also do it using Excel, which I highly encourage learning Excel. You might find it to be far more convenient to use on some problems. So we're going to get our feet wet with Excel a little bit. So let's go ahead and dive right in. We'll do the calculator way first, just because most people at Citrus right now are doing the calculator method. So let's go ahead. And step one with these is always to draw a normal curve. So we draw a normal curve, and it's not just any normal curve. That's kind of a bad normal curve. Let's draw a better normal curve. It's not just any normal curve. This is a standard normal curve. So there are differences, and we need them for our calculator. So there's a standard normal curve, and then there's just a regular old normal curve. So we have standard normal and normal. A normal curve uses x values. The mean, which could be a population or a sample mean, could be any number. We don't know. It's determined by our data. And then we also have a sigma, or it could be an S if it's a sample. That also could be any number. These things are not standardized. Not cool, right? So standard normal curves, they use z-scores. They have a mean that is always 0. And a sigma, a standard deviation, that is always 1. If you ever wonder what this formula, right? The mean minus x over sigma, that's what this formula does. It actually takes us from normal distributions and translates us over to standard normal. This is really, really great if we want to compare like two sets of data. It's really, really useful to use z-scores. And most people, when you say z-score, because it's been standardized, if they say a z-score of like 5, that is insanely good. If someone has a z-score of 5, like if their shooting average on free throws has a z-score of 5, that's like incredible. So, but if you were to say that about a normal distribution, that could mean any number of things. Like who knows? You would have to see the data and sort of get a feel for the other things in the data. So this is important to know because the calculator is going to want these values. So let's go ahead and graph it. Now the middle is the mean. You might make an x value one and a z value one. The x value one would have whatever the mean was for that sample, like we talked about over here. And the z value one will always have 0. So since we're doing z-scores, it's 0. And then we're going to go over here, and somewhere over here, right on the positive side, is 1.92. That's our z-score that we're interested in. And we want to the right of this z-score. So we're going to go ahead, drop a line, and split the curve into two halves. There's going to be a left half and a right half. And we're specifically interested in values that are always greater. In fact, let me make the left half a different color just because that will be very useful. So here's the left half. It's green. Now on the calculator, it's going to want to know, since we want this right area. So on the calculator, it's going to want to know the lower bound and the upper bound. So the lower bound's where you start. So we're starting right here. And we're going this way. How far? Well, wherever the curve ends. The thing about this is the curve never ends. It goes to infinity. And something pretty amazing about this is, even though this curve goes from negative infinity to infinity, meaning that this line will get closer and closer and closer to this line forever, and they will never touch. So there's always a space between them. There's always a space between these two lines. And this space, even though there's always a space, if I were to ask you what's this space we call the area, if I were to ask you what this area is of the whole curve, you might think it's infinity, right? Because we're going from negative infinity to positive infinity, but it's actually not. It's actually 1. Pretty amazing. We're going to need to know this for the chart value, but it also kind of makes sense, right? Because that's 100% of the curve. It's 100% of the area. If you want to know why this is true, you'll have to take calculus 2, and you'll get into something called convergence, which is really, really nifty. But in this class, we just accept that the area underneath it is 1, and it's a really amazing, useful tool. So in the calculator, it's going to want the lower boundary and the upper boundary. Well, the upper boundary is infinite. And we're going to talk about how to put that into calculator because infinite is sort of a problem. So let's go ahead. Let's grab our calculator here. And we're going to just boot it up. And let's go. And now this thing, this curve, is called a distribution. And so it's a normal distribution or a standard normal distribution. And so what we're going to do is we're going to go to the distribution menu. It's right here. It's in blue. So since it's in blue, we're going to hit the blue key and then click it. It'll bring us up to the distributions. Now we want number 2. You can just hit 2 or you could come down 2 and hit enter. But we want the normal cumulative density function. What this does is the PDF, this top one, you might be wondering, why don't we pick PDF? PDF will only find like one spot, but we want all of the spots bigger than 1.92. We want everything to the right of 1.92. We want all of them. So we want to accumulate them. Hence we use cumulative density function, the CDF. Now you don't usually mention this in class, but that's why we pick CDF. So we go ahead, we pick that. And it wants our 2 boundaries. Well, we talked about our lower boundary. We start at 1.92. So we put 1.92. And we go to infinity. But how the heck do we type infinity in a calculator? There's no symbol for it. But what infinity is, in our case, what this is it's just a big number. And the way you could type a really big number inside of a calculator, in fact, this is total overkill, but we'll do it, is we can type a 1 with an E and then 99. What this says is a 1 with 99 zeros after it. A huge number, so big, it's basically infinity for what we're doing here. So you could actually just type 25, and that would be huge. But that's only because we're using the standard normal. That might not be true for normal curves. So by default, we err on the side of caution, just in case you get in the habit of typing this. It's better to just type 1E99 just for like habit's sake. So we're going to come over to upper and we're going to type 1. And then the E is a special E. It's right here in blue on the comma key. So since it's blue, we hit the blue key, the second key, and hit it. We get an E. Now, you'll see people write 2 E's, and you only need 1 for the calculator. We're going to put 99. And then remember, since we're dealing with z-scores, see, if this was a normal curve, we would use the mu and the sigma, the mean and the standard deviation for your data. But here it's a z-score, so we use 0 and 1, and it's already set up for that. But it's important to know that this is why we don't change it. And if it was something else, we would have to make it 0 and 1. We're going to hit paste and then enter, and we get out the area there. So it actually tells us there. So that's the area. That is what this is. That's the space between, whoops, I am erasing things I don't mean to. That's the space between these 2 curves here. And this expresses a probability. So what we would say is the probability that z, and now we write probability kind of like a function. So we write a big P with these parentheses. This is like the really formal way of writing it. We would write the probability z, and we want z to the right. So this probability, it's always to the right, meaning it's always bigger than 1.92. What that means is we do not include this line where it's equal to 1.92. This line right here, we don't include that guy. So we would actually write z must always be bigger than, it must always be greater than. This alligator would rather eat the z than 1.92. And this, we said, well, this is the fancy way of saying to the right. That's how we would write it. And specifically greater than, meaning it's not equal to. It's always to the right of it. And this is going to be equal to, according to our calculator, 0.0274. Now, I would recommend going to 4 spots just because a lot of charts go to 4 spots. And so just being consistent. Your teacher may tell you some other number of decimal places. So this would be our answer. Now, the procedure itself is very, very simple, but understanding why we do the things we do is pretty important here. So let's go ahead and now do it using the chart. Now the chart has a bit of a problem. The charts we use, at least typically, only give us area to the left. It gives us the green area. We're going to call it area to the left, AL, area for the left. This area to the right, we're going to call it AR. Well, it doesn't tell us that. Only the chart lists values for AL. So if we looked up 1.92 in our chart, we would get area to the left. In order to deal with this, we notice that if we took this area to the left and added it, if we added these together to area to the right, that's a plus sign. I wrote it at an angle. Here we go, plus. Then we would get the whole curve. It would cover everything. And so that's 100% of the curve. And the area underneath this curve, even though it goes to negative infinity and positive infinity, is actually 1. You have to take Calc 2 if you want to understand why that's true, but it is true. And so we can say this. We can say that 1 is equal to the area to the left plus the area to the right. And if we want area to the right, we just have to subtract this to both sides, area to the left. And we get 1 minus the area to the left is equal to area to the right. Now, if you're not comfortable with this algebra, there's another way of thinking about it. Here's our whole curve, 100%. It's 1. If we want just this part, then from our whole curve, we should take away area to the left. So I just take it away, I erased it, and we are left with area to the right. Well, that is what this is saying. If we have 1, we take away, we subtract off area to the left. So we took it off of the, this 1 is basically all area underneath the curve, all area under curve. If we take off the area to the left, we're going to be left with area to the right. And so this is an incredibly useful formula. So we can look up our chart and just do 1 minus whatever our chart tells us, and we'll get area to the right. So let's go ahead and do that. So we want to look up 1.92 on our chart. So go ahead, go to your z-score chart, and we're going to just write out what we want here. So there's a positive side and a negative side. We are dealing with a positive z-score, so we go to the positive side. And our z-score is 1.92, 1.92. The way this chart works is the first 2 digits, 1.9, they go to this column, to this stuff. The second 2 digits, or the last digit, I should say, 2, goes to this top column. And the reason for this is, if you were to split it, so we have 1.9, and then if we put 0.2 as its own thing, we'd have to put some zeros in, right, to make it so that when we add them, it's 1.92. That's why it's 0.02. So we would actually look at 0.02 here. But you can look at it as just whatever the last digit is, find it on this line. But that's how the chart works. That's how you think of it. So first we find 1.9. So we come over here, we say, well, 1.9 is right here. And then we find 0.2. 0.2 is right here. And we find this point where they cross. So we come like this, and we come like this. And we find that they cross at this value right here. 0.97257. And it's important to note on this chart too, it even tells us this is, let me move this calculator out of the way. This is area to the left of the z-score. So we are specifically looking at areas to the left. So that 0.97257, area to the left. So if we come in here, we use our formula, we've got our area to the left now. So we say 1 minus 0.97257. What is that? It should be very, very, very close. It should be the same as what's over here. Now there might be small rounding errors because that's a chart basically does what a calculator does and just rounds at a lot of spots. So your chart might only have 4 spots of accuracy. That's totally fine. It should be a number very close to this. So we do 1, well, go ahead, turn it on. We do 1 minus 0.97257, and we get that number, 0.02743. If we look here, this is, we rounded on this one. And so we look and we say, hey, these are super close. This is the same value, off by 0.0001 because of a rounding thing. So we see a confirmation that this is indeed a way. This is a way to check it. If you want to do it 2 ways and check your answer, you can do it that way. Now there's one other way we're going to do it. We're going to do it using Excel. So in Excel, go ahead, open it up. So in Excel, just open a new file. So you should have something similar to this. There's just nothing anywhere. Click on a box, and in this little area, this typing area, you're going to hit enter. This lets Excel know that you're going to do a formula. And Excel can do the same thing as your calculator. So we can type, the function you're going to want, all capitals, is normal or norm.dist. So you're going to type this. And so this is what's called the function call. So this is the function itself. This is what we're going to do. And we're going to fill it with what it wants. And you see here, it wants an x value, a mean, a standard deviation, and whether or not it's cumulative. And so we know that we want cumulative because we want the area, right? We don't just want 1 point. So our x, we actually know, since we're doing a standard normal, our x is actually a z in this case. So that's the 1.92. And we hit comma. That lets it know we're on the next spot. It even makes it bold for us. And then the mean, right? Well, the mean, since it's a normal distribution, a standard normal distribution, it's going to be 0. And the standard deviation will be 1. And we do want cumulative. So we're going to hit 1 to tell it that it's true. So a 1 means yes, do cumulative, it's true. And if we hit enter, we get 0.972571. So this is the area to the left that we got earlier. We don't want this area, right? So what we're going to do is we're going to come back in here. And before we type this in, we get our answer. We want 1 minus this, right? From our formula. We want 1 minus this value. And we get the same thing. So this is to get the area to the right. If it was just area to the left, we wouldn't have to do this 1 minus, but that's how you do it in Excel. And by the way, at the end, you need to hit enter, because if you actually are editing in here and then you click on another box, it'll put that box's number. So this is column C, number 1. So it'll put C1. It can be extremely frustrating, but hit enter to leave it. And that is how you do it with Excel. So you could perhaps write this down as your work, and then you see I just did it. Oh my gosh. You can hit Control Z to go back. You could perhaps write this down as your work, but you still need to write the answer out all fancy like we did right here. Now let's go to B. Now B is a piece of cake for the chart method since it's already to the left. So now knowing all these things that we know, we can go much faster now. So we could draw out our curve. We can draw our amazing curvy bell. It's a z-score, so the middle is 0. This time we want negative 0.44, so we put negative 0.44. We want the area to the left, which is this area. The chart, let's do the chart method first. The chart tells us this. The area to the left, it tells us this. And so if we look at the chart, we say we want negative 0.44. So we go to our curves here. Let's erase what we have here. So on the chart, it's a negative z-score, negative 0.44, so we go to the negative side. And if we write it out, it's 0.44, right? We can insert a 0 there. So the first two numbers and then the last number. So we want to look up 0.4, which is, let's just come down here. Negative 0.4 is right here. And then we want, the last one's 4. So we go to the one with a 4, which is right here. And we map out where they cross. So we come down and we come down and they cross right here at 0.32997. So we simply come back and we'll write that down so we don't forget. 0.32997. That's this area. But writing it like this, some teachers might be okay with this, but usually you want to express that this isn't just a number. It's a probability. And so we'd say the probability that z, so we put these parenthesis marks to tell it this is function notation. And then we say that z, and we want specifically to the left. So we don't want to include the line. So there's no equals to included for the line. It's always less than, right? So these values will always be less than 0.44, negative 0.44. So we put less than. The alligator would rather eat anything but the z. It's less than that. And we put negative 0.44. We say that this probability, when you do this, that's the same thing as 0.32997. They're equal. So there you go. This is the chart method. Since the chart already gives you area to the left, it's really easy to, you simply look it up and then you got to write it out. All right, now let's say we do it using the calculator. Well, in the calculator, we're going to have a lower bound and an upper bound. And in this case, our lowest bound is way over here at negative infinity. So we're gonna also type a big negative number like we did for the positive side. So we're just gonna type negative 1e99. It's like a 1 with 99 zeros. It's negative whatever that is, a huge number. And then our upper bound, so this would be our lower bound. Basically negative infinity is what we're trying to do. And then our upper bound will be this guy over here, negative 0.44. So this would be our upper bound. So let's go ahead and pull up our calculator. Go ahead and turn it on. Go to the distribution menu. Again, since it's blue, we hit the blue button. Then we go to normal CDF because we want the whole area. We don't just want a point. And so we're going to go ahead and enter. And now our lower bound, as we just talked about, is negative infinity. We're going to do that by typing. Now you need to type it with the negative symbol here. It's not minus. On this calculator, they're different. So that you have to use this negative button. -1. And then we want the E, which is right here in blue. So we hit the blue button. And then 99. Actually, 1E9 would work because this is a standard normal. Anyways, now for the upper, we would go ahead and do the negative 0.44. This is where this is our highest value. So this is negative. That's a good way of looking at it. This is our highest value. And I accidentally pushed minus. Minus won't work. You have to use the negative key. 0.44. Again, we already know that we're dealing with a z-score, and a z-score means we're dealing with a standard normal distribution, which means the mean is 0, standard deviation is 1, and we hit paste. And we get the same thing, 0.3299, and then you can see this one's rounded to 7, but it can keep going. And now finally, let's do it in Excel. So let's go ahead, we'll go back to Excel, and in here, we don't want area to the right, so we just want regular old normal distribution. And this time, our x value, which we know is actually a z, this is just how Excel could do anything. As long as we use 0 for the mean and 1 for the standard deviation, this is now basically a z. So we want negative 0.44, so we put that in. And we do want cumulative on. And now we just hit enter. We get 0.3299, and again, we could actually get very accurate in Excel. You can actually change how many decimals it'll show. It's pretty awesome. And so we can see we get the same thing as what we got here. And so this, if you were to write the answer on your homework or your test or whatever, this would be the answer, and your work would just be whatever method you used. So if you have any questions about this, let me know, subscribe, and we'll catch you in the next problem.